All right, in this video, I just wanted to quickly go over some probability terminology and notation. So the first definition in probability we're going to talk about is something called a probability experiment. So a probability experiment is an action through which results are obtained. So you do something and you get results, meaning you flip a coin, either get heads or tails. You roll a six-sided die. You're going to land on either numbers 1 through 6. Those are all probability experiments. The results of these experiments are what we refer to as outcomes. So the outcome is the result of a probability experiment. A trial is just one instance of an experiment. For instance, if our experiment is flipping a coin, one flip of that coin constitutes what we call a trial. A sample space is what we refer to as the collection of all possible outcomes. So I know coming from our last unit, that seems a little out of place here, but sample space in the probability world, that means the collection of all possible outcomes. An event, on the other hand, that is that's the subset of a sample space. So the sample space is everything, an event is just part of a sample space. Let's get into an example here. Suppose our probability experiment is rolling a six-sided die. What is the what is the sample space for this experiment? Okay. Suppose our event is the case where we must roll an even number. What are the outcomes in this event? Okay, so let's take it from the top here. So our probability experiment is that we're rolling a single six-sided die. Okay, just think of a cube with the numbers 1 through 6 on it. What is the sample space for this experiment? We're going to let, for this example here, I'm going to let S denote sample space. And our sample space will be a collection of outcomes. In fact, it's a collection of all possible outcomes. And when you roll a six-sided die, you can either land on a 1, a 2, 3, 4, 5, or 6. So that is our sample space. Let me make sure that's clear here. So our sample space are the integers 1 through 6. Okay. The other part of the question asks, suppose our event is where we must roll an even number. We must land on an even number. So what are the events? What are the outcomes, that go with this event? So in this case, let's let E represent event, the event where we get an even number. And so ask yourself, what are the possible outcomes that will go with this event? Well, since it has to be an even number, it's either going to be 2, 4, or 6. Once again, the curly brackets indicate a set there. But as you can see, the event has some of the outcomes from the sample space S. All right. Let's see. Next definition, mutually exclusive events. So mutually exclusive events are two events that cannot occur simultaneously. Okay, so think of it. If the two events cannot occur at the same time, they are said to be mutually exclusive. If the two events can occur at the same time or within a single trial, then we say the events are not mutually exclusive. For example, let's let event A be the event that we roll the number 6. We're rolling a single die. And let event B be the event that we roll an even number. Are these events mutually exclusive? So what you're asking yourself here is that on a single roll, is it possible for us to get both a 6 and an even number on a single roll? Well, certainly that is possible, right? Because 6 is an even number. Because we're able to have 6 and an even number occur within the same instance, within the same trial, that means that these events are not mutually exclusive. Okay. Once again, that is because these can occur within a single instance, so they are not mutually exclusive. Well, the second example, are the events rolling 3 and rolling an even number mutually exclusive? Let's think about it. On a single roll, can we get both a 3 and an even number? No, that's impossible because 3 is an odd number. So in this case, because the two events cannot occur within a single instance, within a single trial, these events are mutually exclusive. Okay, so hopefully that clears up the definition of mutually exclusive events. Okay. A topic that's often confused with mutually exclusive events, but separate from it, is the concept of independent events. So here's a definition. When the occurrence of one event does not affect the occurrence of another event, then the two events are said to be independent. Events that are not independent, meaning if one event happens, that affects the likelihood of the other event occurring. In that case, the events are called dependent. Okay, so I know it kind of sort of sounds like mutually exclusive, but it's a different concept here. For example, let event A be the event where we do not pay a parking meter. Let's let event B be the event that we receive a parking ticket. Are these events independent or dependent? Well, you have to ask yourself, are these events related to each other? Are these events affecting each other? In this case, yes, because the fact that we did not pay the parking meter, that's why we got a parking ticket. Because there is that relationship, we say that these events are dependent. These events are dependent because they are related to each other. They're affecting each other. Okay, just a few more definitions here. So next, we can now get into the concept of a conditional probability. And so, well, a probability is the likelihood that something happens, right? So a conditional probability is the probability of an event occurring, given that another event has already occurred. Okay? I like to think of conditional probabilities as insider trading. It's like you know something has happened. Now the question is, what's the probability that this other thing is going to happen, given that you already know some prior information? We're going to use some special notation here. We use the notation, let me highlight it here, either P, so P means probability, and then you're going to see A with that vertical line there, B. Or you're going to see P, probability of B with that vertical line A. That vertical line means given. So for example, the probability of B with that vertical line A, we read that as the probability of B given A. What that means is you're trying to figure out what's the probability of event B occurring given knowing that A has already happened. Okay, in that notation, we call A the given event. Okay, the probability of A given B, now what we call the condition flips. The probability of A given B is the probability that A happens given that this time you know B has already occurred. So it's very important that you understand which event has the condition placed on it. What I mean by that is which event do you already know has happened for certain. Okay, here's an example here. Let Q be the event that the sum of two dice rolled is greater than 8, given that the first die rolled was a 5. Let R be the event that the first die rolled was a 5. And I left out some information here. Let's let, Q is the event that the sum of the two dice rolled is greater than 8. Okay? Express this as a conditional probability. So what they're trying to do is take the events R and Q and put them in the correct order within that conditional probability notation. Okay? So to do that, this is what we do. P, this is the probability of, we're trying to get a sum of that's bigger than 8, greater than 8, given that the first die roll was a 5. So this is the probability of Q getting a sum is greater than 8, given, that's what the vertical line means, that the first die roll was a 5. And they said event R represents that particular scenario. So this is the probability that we roll a sum greater than 8 of the two rolls, or the two dice, excuse me, given that the first die was a 5. Okay, so that wraps up this one. Hopefully this will help you guys out with your homework. I will see you in the next video.